We're going to be looking at what this unit is titled, Sine Functions, and we're going to be looking at an application of what is called a sinusoidal event. So sinusoidal refers to this unit being called sine functions, and that also refers to the whole idea of sine as in sine, cosine, and tangent. A sinusoidal graph is a special type of periodic graph, and basically it is a wave. So it kind of goes up and down and up and down. It's curvy, not zigzagged. So it's repeating a cycle because it's periodic, and it just keeps going up and down like that in a curved fashion. So whenever an application or a graph says it's sinusoidal, it will have this type of shape. Now, it may start at the top, it may start at the bottom. From here, it may go up, it may go down first, but it's got that pattern. So in this example, an ocean tide is an example of a natural sinusoidal event. So the tide comes in, the water level goes up, the tide goes out, the water level goes down. The tide comes in, the water level goes up, the tide comes out, the water level goes down. At high tide, the height of the water is 12, so that's 12. At low tide, the height of the water is 3, so down here is 3. The ocean tide reaches its maximum height every 24 hours. And we're going to sketch a graph of this phenomenon for 2 complete cycles starting at high tide. So the first piece of information is at high tide the water is 12, and at low tide the water is 3. So that means the maximum is 12, and you got to put in the units, so that's meters, and the minimum is 3 meters. From the maximum and the minimum, we can get the amplitude and the axis of symmetry. So you might want to remember that the amplitude is the maximum, which is 12, minus the minimum, which is 3, divided by 2. Yes, 9 divided by 2, which is 4.5, and the units is meters. The equation of the axis is max plus min, so 12 plus 3 over 2. So that would be 15 over 2, which would be 7.5. And remember that you need it to be an equation. So normally we would start with y equals, but in this application, instead of the y, it's actually h. So the equation then would be h equals 7.5, not y. It would be h. Now the other thing is, the ocean tide reaches its maximum every 24 hours. So that means from here, it reaches its high tide again every 24 hours, and that is 1 cycle. So that means the period is 24 hours. Please don't forget to put units in when we are dealing with word problems. Now, the domain and range. Theoretically, the tide would continue indefinitely, so the domain would be XER, but in this word problem, because it is using the variable t for x, your domain would be TER. And for the range, the minimum is 3. And instead of y, we're going to use h. And the maximum is 12. And then you're going to write HER. So that's how you get the information from the graph, or you get the properties by reading the information on the word problem. Now, what I'm going to be showing you is how to graph this. And there's lots of different ways to graph this, but this is the way that I would have you graph it. So, in order to graph, these are the steps that you would want to take. First thing that I would have you do is to label the axes and the scale. Now, in this case, the scale's already been labeled for you. Sometimes it isn't. The Y, you'd have to know, of course, what the maximum and the minimum were. So you'd have to make sure that it showed 3 and it went up to 12 at least. For the X scale, you would need to know what the period is, which is 24 hours, and you would need to know how many complete cycles there are. So because we want 2 complete cycles and each cycle is 24 hours, you would need to make sure that your x-axis goes up to at least 48. The second thing that you'd want to do is to draw in the axis. So the axis is at 7.5. So what you would do is at 7.5, you would draw where the axis would be. Using a ruler. I don't have a ruler on this, but draw in a ruler. The third thing you want to do is to make note of the maximum and the minimum. Now, in this case, it's very obvious what the maximum and minimum is because we've been told. So the minimum here is 3, and the maximum is up at 12. But sometimes it's not as easy to figure out what the maximum and minimum are. So one thing that you can do to figure out the maximum is, if you know what the axis and the amplitude is, the maximum can be found by taking the axis and adding the amplitude. And the minimum can be found by taking the axis and subtracting the amplitude. There's lots of different ways that you can work this out. Sometimes you know the minimum and you know the amplitude, but you don't know the axis. So you could find that the axis is the minimum plus the amplitude, or you may know the maximum and then you could subtract the amplitude. So those are some other little formulas depending on the type of question that is given to you to find out this information. The next thing you would need to know is, what is the starting point? Where are we supposed to start this graph? So the graph says we want to start at high tide. So that means on the y-axis, we want to start up here. Now for the next part, I just need to explain something. In this little diagram up here, your axis would be in the center here. It's not exactly center, but let's pretend it is. So if this is your starting point right here, then to get to the finishing point, we're going to be plotting 4 key points. So once you have the starting point, your next point is going to be on the axis. Your next point is going to be at the minimum. Your next point is going to be back on the axis, and your next point is going to be up on the maximum. So those are called our key points. And they change 4 times per cycle. So the fifth thing you're going to do is you're going to find out how often the key points change. So because they change 4 times, like after the beginning they change 4 times in one period, what you're going to do is take your period and divide it by 4. So in this case, our period is 24. And when we divide that by 4, we get 6 hours. So that means your key points are going to change every 6 hours. So from the maximum, the next point is going to be on the axis, and it's going to be 6 hours later. So at 6 hours, you're going to be on the axis. Then 6 hours later, we're going to be at the minimum. So 6 hours later is 12 hours, and now we're going to be at the minimum, which is 3. And 6 hours later, we're going to be back on the axis. So 6 hours later is 18 hours. So at 18 hours, we're going to be back on the axis. And 6 hours later, which is 24 hours, we're going to be up at the maximum. And we need to show 2 complete cycles, so we're going to do this again. 6 hours later is 30, back on the axis. 6 hours later is at 36, so we're going to be at the min. 6 hours later is 42 on the axis. And 6 hours later is at 48, up at the max. And when you graph this, remember it needs to be curvy, not zigzag. So you are going to, it doesn't have to be perfect, because even I'm not going to make it perfect, but you want to make sure that it looks like it's curved and not zigzagged, and it would look like this. So that is a sinusoidal application. Then you might get a couple of follow-up questions, like what is the approximate height of the water after 5 hours? So at 5 hours, we can say that the approximate height is about, so approximately 9, what is it, meters? And at 12 hours, well, we know that that's exactly 3 meters. And then at what other times will the height of the water be the same as it is at 6 hours? So at 6 hours, we are on the axis. So at 6 hours, we are here on the axis at 7.5 feet. And you're going to be on the axis, in this case, because you're on the axis twice every cycle. Normally points repeat every cycle, but in this case, you're on the axis twice a cycle. You're at the maximum only once per cycle, and you're at the minimum only once per cycle, but you're on the axis twice per cycle. So in this case, you're on the axis at 6 hours, and then 18 hours, and then 30 hours, and then 42 hours. So you can write it like this. So at what times will the height be at the same water level? So you can write it as 18 hours, and then 30 hours, and then 42 hours. And then what you want to do is put dot, 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 and the dot, dot, dot means it continues. Or what you can do is you can say every 12 hours after 6 hours. So it's starting at 6 hours and it's every 12 hours after. So everything we've talked about is written down in the information below. And that is how you interpret a word problem and graph it and answer questions and list the key properties here.